Hello everyone, welcome to my channel Code. My name is Rohit and if you are new to this channel, do subscribe to my channel. Now let's jump to the question. So the question is reverse a linked list. Given a linked list of n nodes and the task is to reverse this list. So let's understand the question with the given example. So here input is 1 points to 2, 2 points to 3, 3 points to 4, 4 points to 5, 5 points to 6 and 6 points to none. What we have to do, we have to reverse the linked list in such a way that this node points to its previous node instead of next node. So we have to cut the link of the next node and points to its previous node. Okay. So here we see that 6 points to 5, that is the previous node, 5 points to 4, 4 points to 3 and so on. After reversing the list, this is our final output. Always remember that we don't have to reverse the data part, we have to adjust the link, that this link points to the previous node. Okay, so now let's move towards the approach of this question. So let's take example 1 points to 2, 2 points to 3 and 3 points to none. Our output is 3 points to 2, 2 points to 1 and 1 points to none. Okay, so this is our final output and this is our input. So what we have to do, we have to just reverse the link in such a way that this node points to its previous node. So this is very simple approach, that we have to just adjust the link to the previous node instead of next node. We have to cut the link of the next node. Okay, so now whenever you approach towards the question, always think about the edge cases or corner cases, and edge cases or corner case is very important. So what is the edge case or corner case in this question? So if I give you the empty linked list, can you reverse the linked list? No. So what you have to do, you have to just return the empty linked list. And the another edge case is if there is only one node present in the linked list, then you can't reverse the linked list. You have to return the node as it is. So the two edge cases is if the linked list is empty and if the linked list contain only one node, then return the head node, and if the linked list is empty, return the empty linked list. Now, what you have to do, everything is sorted. We have done the approach. Now let's jump to the coding part. So take two variable, frame which initializes to none and current which initializes to head. Here head initializes to the first node which stores the address of the first node. So here current is equal to 1. Now we have to traverse till the last node, that is we have to traverse till there. So what we have to do, we have to traverse till last, so that's why we use while loop. While current is not is equal to none. If current is equal to none, we have to come out of the loop. That if current is equal to none, then we traverse till the last node of the linked list, then we have to come out of the loop. So now after doing this, we have to check that current is equal to null. No, current is not is equal to null. Then what is the next step? Take another variable, that is next, which points to the next node of the current node. Here next node of the current node is this node. So the next node of the current node is 2. Okay. Now what we have to do again? So the current node now points to its previous one. Let's do this step, that current node points to this previous one. Now 1 points to previous node, and after that store the current variable, store the current node in the previous one. So what is our current node? Current node is 1. So store the current node in the previous pointer and store the next node, that is 2, in the current pointer. So current now becomes next, that is 2. After that repeat the same step. Now current is equal to 2. So we have to check that current is equal to null. No, current is not is equal to none. Now repeat the same step. What is the same step? Current points to its previous node. So here 2 points to its previous node. What is our previous node? That is 1. So current node points to its previous node. Now again repeat the same step. We have to just store the current value to previous and next to current. So what is our current? Current is our 2. So store the 2 in previous and store the next in the current. Okay. After that, we have to check again that this node, that is current node, is equal to none. No, current is not is equal to none. So we have to do the same step. That next is equal to the next node of the current, that is none. Our current is 3 and next of the current, that is none. So we here store none. Okay. After that, do the same step, that 3 points to 2. So here 3 points to 2. After that, repeat the same step. Here current is stored in the previous pointer, next is stored in the current pointer. So what is our current? That is current is 3. Current is stored in previous, and what is next? Next is none. So none is stored in current. Now the current is equal to none. Current is equal to none. So we have to come out of the loop. After we come out of the loop, what do we see? That we have reversed the linked list, but the head pointer still points to this node. We know that prev is equal to 3. We have to do that head must point to this node, and we know that prev variable store the address of this node. So what we do, we initializes head is equal to prev, that prev which store the address of the first node. Now head points to this node. Head points to this node. So our final linked list is 3, 2, 1, and 1 points to none, and head pointer points to this node, which store the address of this node. Okay. So our final linked list is this after reversing the linked list. Now what is the time complexity of this question, and what is space complexity of this question? So the time complexity of this question is, we have to traverse always up to the last node. If there is nth node present in the linked list, then we have to traverse up to nth node. So the time complexity is Vigo of n, and the space complexity is Vigo of 1. That's it. Our final question is done. We reverse the linked list, we point the head to the this node, we find the time complexity, we find the space complexity, we find the edge cases, corner cases, and this is done. Now let's jump to the code part. So this is our code. So this contains the edge cases or corner case. If head is none or head dot next is none, we have to return the head value. We have to initialize two pointer which points to the head and current points to the head. We have to use the loop until current is not is equal to none. When current become none, we have to just come out of the loop. So we have to repeat the same step. After that, head pointer, when we come out of the loop, head pointer points to previous node and we return the head value. So now let's submit our solution. Yeah, our solution is correct. Hope you like it. If you like my channel, do subscribe to my channel and share with everyone, and do subscribe for the upcoming videos. Stay tuned to my channel. Thank you.